Okay, next up, we have a panel with all our speakers taking questions, which will be moderated by Scott Renfro from Facebook.
To sit down and listen to what the speakers had to say. As Ryan said, my name's Scott Renfro. I'm a software engineer at Facebook. I've been here for about 5 years, worked on converting Facebook to HTTPS, deletion, anonymization, differential privacy, and a bunch of other privacy and security things, including several tours of audits with regulators in Europe, which are always lots of fun. I really appreciate all of the speakers coming out and talking today, and please join me in expressing your appreciation. We're going to open this up for questions from all of you here in just a moment, and we have a couple of mic runners, so when we get to this in a second, if you can raise your hand if you have a question, but I'll kick things off first. I just wanted to say I really appreciated the spectrum of talks we had today and the changes that I've seen just in the last 3 to 5 years with different disciplines coming in and working with security and the tighter integration between security and software engineers and moving from a world where security is bolted on or we're like, we can deploy this appliance here or that appliance here or you sit in InfoSec and we'll sit in product development to a much more integrated environment. And several of you are spending a lot of time working with software engineers and I wondered what your thoughts are on ways to help us work better together. Do you have thoughts on that, Ken? What things work really well, and what things do you see triggering bad reactions when working with developers?
Sure. So I actually am a software engineer. So
right.
The biggest thing really is keeping the communication lines open, trying to convey what you're trying to accomplish, rather than just say, just do this.
Mm-hmm. And how much of this do you see in the presentation of the change that's coming versus the actual change itself? I know we sometimes see this where you have to word the announcement, hey, there's new access control coming. If you lead with that, you're probably going to get the knee-jerk reaction because everyone knows what happens when InfoSec rolls out new access control, even if you've put a lot of thought into it. How much have people experienced different forms of communication that help this? Have you tried different approaches?
So one thing we've tried is we've tried to couple any lockdown, so to speak, with an enhancement or a feature, like faster SSH. By the way, we added two-factor, things like that.
Yeah, that makes sense. Yep. Yeah, that I know for us, you mentioned one of the things we have as well, which is a Get Access Now button. So in these transitions, when you're rolling out those new tools, the escape hatch that says, wait, we may not have gotten this perfect, so here's the escape hatch you can use. We're going to know when it gets used, and we can adjust things based on that. A lot of you are working on coming in from other disciplines to security or leveraging information from other disciplines. Just some of you want to share about your experiences, either what disciplines do you think we can learn from, or what can we do within security to encourage more people to come help out and contribute.
Okay, Scott, you're staring at me, so.
Staring at like 4 of you all at once.
Yeah, I think like the biggest thing I've seen from having a non-traditional background is just being able to come in and use those tools that I'm familiar with on these new problems. So I think that that's probably the biggest thing that I personally feel like I've brought to the team. Like I've had different experiences. I know how to use data. I'm familiar with these tools, and also I'm familiar with the ways that I've used these tools in the past, having had that data science background. And now that big data is such a hot buzzword, and obviously like any sort of data is very valuable, and it's going to be a huge opportunity for vulnerabilities in your system. That's what attackers are going to go for. Having that knowledge and being able to share that with my teammates and get that security, building up that security background as well, I think has been really valuable.
Awesome. Kevin, you mentioned something about training up new security architects. Like, what have you found that works well?
So I've only been on the job for a month and a half, 2 months. So, and no comments from the peanut gallery, okay, guys? But a lot of it is just bringing people into the environment, exposing them to. So a couple of my folks have done CTFs and some of the more traditional security stuff, and one of my other folks has more of a traditional CS background, and So just like trying to give everybody exposure to all the pieces of it, you know, seeing what kinds of things are out there in the world. So yeah, you know, send everybody off to a CTF for one day and send everybody off to a UI, you know, seminar for another day, and just like, you know, I'm lucky to have my folks in a position where I can just like, you know, keep throwing stuff at them and give them exposure to a wide variety of things. And trying to find those places where they synergize, where you go, oh, this thing from my electrical engineering coursework, you know, applies over here.
Awesome. Deidre, you mentioned like don't be afraid to jump in.
Yeah.
What were some opportunities that or doors that opened for you that you think were important?
I think I'm basically a web developer in my day job. And when I learned that, no, really, these standards bodies are just a mailing list and people are on them, and it doesn't matter if you are a super lead cryptographer or you're just an engineer who is interested, that was a big thing for me because it was really easy to get on the list. And then it was really easy to just be like, what do you mean by that comment or by that critique on this document? Or, you know, why did you decide to make this decision? And everyone there was accepting. Everyone was there, was like, no, that's not a dumb question. They were like, that's a good question, and this is the answer. And the fact that the two main cryptographers who developed those curves I talked about are on that list, and they directly answered my questions, felt very validating, because I am not from a security background, a cryptography background, or a math background. I am a software engineer. And that was a very liberating feeling, because if I can join that group and I can contribute and actually help and get my answers questions and not feel like I don't belong there, I can go anywhere. I can go to the TLS group, I can go to W3C, I can go to all of these places, and I feel that I can give back. And being an engineer, I can also give back in terms of real people have to implement these specs someday. And I feel like a lot of these standards bodies realize that now. The separation between just security people or crypto people and engineering is coming closer together all the time. So I think they do appreciate, you know, non-experts coming in and saying, if I have to understand the spec and implement it, or I have to understand someone else's code that did implement it because I have to fix the bug that they left 10 years ago, I need to be able to understand the thing that you're writing. So I think that those coming together has been really beneficial to everybody.
Awesome, yeah.
So I would say I've always been a hacker at heart, right, where I've always had that curiosity, but I never thought there was a professional outlet for me until like a few years ago I was teaching high school, and I was seeing my students with that same curiosity, and they were, you know, I was catching them doing bad things that they probably shouldn't have been doing. So channeling them into the correct outlet for that. And I didn't know there was an outlet for that for myself, for my own curiosity, until finally I started getting involved in CTFs and doing some of the, you know, the explosion of a lot of the online resources that are available for people that want to learn about our profession. And then, you know, taking the year off to do a school program in that area, and then haven't looked back since.
Awesome. Yeah, and John and Alex, you guys kind of made a big transition coming from data science visualization into the heart of Carbon Black Bit 9. Like, how has that been?
Right. Well, we'd actually had, I had experience within security. I had worked at a place called Charles River Analytics and worked on probabilistic algorithms for an IPS back when they were a new technology. So I did have some context there. But it is interesting, both security and data science are both those topics that you mention, and people are like, oh, it's scary stuff, you know, let's not talk about that. Or, you know, math scares people. So just in general, I think it was great, you know, the crypto stuff, and just generally encouraging people to not be scared, just take a look. You know, it's going to go in the reading rainbow thing, but but yeah, it's, you know, I think there's, one of the things that I was surprised by is I think there's this separation of expertise in cybersecurity and data science, and I think it's been really hard for people to bridge that divide. And so I've been surprised by the dearth of work that has been done in this area, but it's great for us because there's a huge opportunity in so many different ways that we can apply machine learning within this domain. So I'm really excited to be doing that work at Bit9 with Alex. I didn't mean to hog the whole time. If you want to relate some.
You know, the main point I was kind of resonating with that was this idea of like hacker versus tool, and just a theme I feel like running through a lot of this has been how human a lot of the security things are. That it's not easy to write a rule. It's not easy to make an algorithm. You have this intuitive sense of what looks right and what looks wrong, and that was, you know, when I was first getting into cybersecurity, we had to go and talk to a lot of analysts, and they wouldn't tell us if this, then that. It was like, well, it kind of looks this way, and it looks a little funny, and it worked well for our visualization tools, where we had to really understand that intuitive way, what kind of things they were looking for. So I just thought that was kind of an interesting theme running through this.
Yeah, I think it was interesting where Marjorie's talked about invariant detector, and it was one of the few places I think we've seen at Facebook where you don't have to get an intuitive understanding of the data first, but the machine is actually learning rules that you can go and force, and you only have to go learn the intuitive sense of it when there's a failure. And you're like, okay, wait, something weird happened. Now we'll go look. But yeah, so much of it's been required this hands-on digging in data. So let's transition and open it up to the audience for questions you have from the talks earlier in the day, things folks have said, or just other questions you have for software engineering and security.
Yeah, so I think this theme that you guys have about, you know, the overlap of data science and security is really interesting, and you know, the fact that we're only just starting to do this in a big way now in 2015 is kind of amazing to me. But it looks like it's applied, you know, largely to sort of incident detection and response and things like that, which are obviously very important things. But it sort of seems like it's treating the symptoms rather than the problem, if that makes sense. And I don't know if maybe you guys can sort of speak to where you see that going. I realize that's not really a question.
You want to go?
I'll take part of that.
Sure.
And that's that I think that we've been focused for a long time on sort of, you know, threat mitigation. You know, if we list all of the threats in the system and then we write down next to them what it is that we're doing to make that threat go away, that we've made a safe system. And one of the things that really excites me about the stuff that I was talking about is it gets us away from this whack-a-mole security model and towards a model where we can start to understand the problems at a high enough level that we can control them at a high enough level. So we're no longer running around frantically after the problems. Can start to tackle the root causes, the unsafe interactions.
Yes, Seth.
With us, the main reason that we're doing the classification of malware is so that we can do threat actor identification and tracking. So rather than trying to be purely responsive, where we see malware coming in and we say, hey, this is bad, let's stop it, we're trying to understand who's out there, why, what motivates them, why they're doing what they're doing, and why they're doing it that way. And having a better understanding of that lets us tackle different areas all at the same time, whether it's financially motivated malware trying to rip people off, or state-sponsored, government-targeted malware going after human rights activists. So by understanding each individual, I guess, theater of operation, we're able to expand our coverage to entire areas instead of responding to individual threats.
Great. Another question.
Just to follow up on that one, Seth, you said that the idea is to track these threat groups and actually be able to do something about it, maybe? Do you actually see that being the case? I mean, if somebody breaks into my house, I call the cops, I get arrested, right? On the international scale, that's simply not the case in cyber. So what do you expect?
It does help a lot, whether with crime families and organized crime, being able to track the actors means you can then identify where they're putting their money and actually get people arrested. You can seize their bank accounts. We're using this information for takedowns of that sort. On the other side, for example, with state-sponsored malware that's targeting journalists and activists, knowing where it's coming from, even if you can't put up the person's name or rank in the military or whatever like that on a billboard and then send Interpol to go arrest them, knowing whether these threats are in fact government motivated and who they're going after means that you can provide at-risk groups so journalists, activists, human rights people, you can provide them with tailored training for how to defend themselves against actors with much more money and much more resources, and actually have that education and training be effective for them to protect themselves.
Great. Another question?
Hold on, I'm going to get her first. I'm curious whether you guys have anything to talk about cloud container type of things, because those have become more and more important now, and notice today's topic tend to be lacking in that area.
Container deployments, Docker, anyone? Who's using containerized like deployment at work? You are, Ken?
Yeah, so we've moved some of our stack into it, not all of it. And the biggest takeaway we've had so far is don't run things as root.
Mm-hmm. Yeah. And
it's more of a deployment strategy than an isolation. So it doesn't provide even the security isolation guarantees that you get from like a VPS, which are already, I want somebody to do a VM breakout live on stage at DEF CON a few years ago. So containers provide even less isolation. And so but it's much more useful. We seem to be moving to a world where like the interface between dev and ops is like dev hands ops this container, or maybe the Docker file instructions for building a container, and then all ops has to do is make sure that the secrets get put in the right place and the ports get mapped correctly. And so, like, if somebody offers to let you run your encrypted, your encryption server on Docker host, don't. But if that's like you've got a bunch of systems that you want to deploy stuff onto it, it's increasingly compelling for that. The security story is subpar. Yeah.
Yeah, I know for us at Facebook, this has been much more motivated by getting reproducible deployments and tying automated build systems into deployment and knowing that you have this reproducible software running out in production, and getting away from the world where you have that one magic binary and no one's quite sure what did we compile that from? Did the repo get tagged when we cut that release? Or, oh wait, this actually depended on a source file that never got committed. Getting away from those ad hoc development and deployment environments to where it's repeatable, and then really getting to where you're decoupling other things that should be configuration, like where does this host run, right? You want to start forcing out of source code, whether it's secrets, which is like a terrible place to hide your secrets, is in the source code, or things like IP addresses or even ports. Going to these containerized deployment really seems to help all of those operational aspects. And I know for us, for example, the way that deployment works around secrets is that the container basically is deployed with software, and then the secrets are populated into it as a separate step. So you can really decouple those two, which is, I think, one of the important steps in maturing that software development process around deploying production services. Cool. Another question?
Hi, this is for Seth. So it seems like Apple and Google let through a lot of malware still that I guess you catch. Is there something that they can be doing that's more proactive in a world where they kind of by default let everything through?
Well, they're not letting everything through. Apple in particular was a lot better at it, but their strategy of having it be restrictive meant that a lot of that was also just restricting what users are allowed to do in apps that are redistributed through the App Store. There can be more work into it, but we hope that they don't, because that's the whole reason our company exists, is to pick up their slack. They could be doing what we're doing, yes. There is absolutely more that they could be doing. But part of the reason that we exist is because other distribution sources are saying that they would rather outsource that to a company that does that specifically, rather than try to pick something else up and handle all of the other problems that they're dealing with as well.
So Seth, on the Android side, how much of a problem are the proliferation of different app stores and just non-app store deployments. Like we've seen like Facebook in pink or Facebook in green or other repackaged APKs that are really popular in certain countries, or certain carriers will give you a phone that have customized APKs on them already.
Do you remember the slide earlier in the day with the dog drinking coffee with a house on fire? So everything's fine. That's pretty much the state of things for everything, and Android is even worse. There are actually more panels to that comic where it gets worse. There are entire app stores, for example, in Vietnam, most apps downloaded there. There's a local app store that you can submit any app to it, or even just a URL to an app, and it will go out, it will grab the app, it will decompile it, it will inject adware into it, it will recompile it, and then put it up on the App Store for availability. So I think the general state of things is panels 3 and 4 of that comic. Go look it up, it's a good one.
Awesome, another question.
Hi, this is for the Facebook presenters. Thank you very much for sharing some of the techniques you use inside Facebook. The question I have is, there is invariance, there is OS query, then there is the labeling. Now, I assume all of these things take resources from the production servers, right, as you run your background tasks. How much resource do you consume in doing these infrastructure tasks? And when does Facebook decide that, you know, do you add more processors or more resources? At what point, how do you decide that, you know, value versus, you know, the resource consumption?
Do you want to answer that, or you want me to?
Sure, yeah. So I think largely a lot of the stuff that we've built, there is a huge emphasis on performance. Like Marjorie mentioned, like adding the invariant detector added very little overhead. I think that whenever we design a new system, it's definitely a priority. Oftentimes we find that the trade-off is worth it. So not only are we, so if we're launching a new tool that improves developer productivity and we have to take like a small hit on performance, we'll often take that hit. But generally, performance is an issue. The tools that we end up developing, that's something that's always in the back of our minds. And we try to prioritize that as much as possible. And it's because the things that we're building are so important to the way that we do development, and because we think that secure development is so important to our iteration speed and our ability to push new code out, that we do decide to take those hits sometimes. It really varies. So it's really on a case-by-case basis. I can't really, I mean, yeah, like if it's like going to be like a 300% CPU increase, we probably will not do that. But yeah, it just really varies. It depends on the particular thing. I don't know.
Yeah, there's some good examples of that, I think. So anytime you're building a website, cross-site scripting's like the security scourge of you trying to get this website shipped, and keeping cross-site scripting away seems to always be this challenge. And just before I got to Facebook, the engineers in the company were suffering from really 2 problems, one of which was cross-site scripting flaws, and the other was malformed web pages. Like, hey, you didn't close the B tag, the whole rest of the page is bold, this is terrible. How do we deal with this? And a really smart engineer at Facebook said, you know, I think we should do something different. And this was really the first time at Facebook that an engineer had said, you know what, we shouldn't be constrained by the language we happen to use to write the site today. So we were using PHP even then. And he said, you know, the options here are kind of terrible and more terrible. We can concatenate strings of HTML, or we can use some template system that's like not very flexible. We need something better than that. And so they started a project called XHP, which basically let you write XML as a first-class citizen in the language. Initially, we were on Zend PHP, the open source PHP, and this required a translation step before it hit the PHP interpreter, but every tag actually got translated into an object at runtime, and it was a runtime error to not close a tag or to close a tag in the wrong order, but it was also gave the code that was generating the output context about how that output was going to be used, so you could wait and escape when you knew this is going to be in the top level of the document. This is inside of a value of an attribute, inside of a tag. I know how to escape stuff correctly. XHP was a pretty fundamental change to the development process at Facebook. And it cost us at the time, it costs us today still about 2, maybe 3% of our site CPU, which you can imagine that's a pretty big number. But the value we get out of that by not shipping pages that are broken with malformed tags, not having constant white hat reports about the next cross-site scripting flaw on Facebook, that's just hugely valuable. And it turned out to be a much better way of building web pages. You can have basically synthetic web pages or elements that are composed of other HTML elements, and you end up with really clean code. So this was a case, and I think we heard several of these other cases today, where people are finding a solution for a security problem that's also a solution for an engineering problem. And I think those are the cases that are no-brainers. Like, you're willing to make the investment when you have plenty of value in multiple dimensions. Cool. Other questions? Right.
I also just kind of want to add to that answer that it's not always a trade-off. I feel that the work we're doing on labeling data is allowing us to anonymize data and move it to colder, cheaper storage. And the work with static typing in Hack actually enabled additional optimizations in the compiler that actually gave us performance benefits. So a lot of times you can actually win on all 3 counts.
Absolutely. And it was something Kevin was talking about earlier, building safe systems. That was really interesting with us deploying a type checker. So we're running PHP. It's an untyped dynamic language. And we, people that had a security background or interest, wanted a strict subset of PHP. This turned into an incrementally typed language with a real-time type checker. And it turned out to be one of the other most popular changes to engineering at Facebook in the entire time I've been there. Because what it meant was, as I'm typing code, every time I hit save, the type checker tells me what bug I just introduced. But way more powerfully, it also tells me when I'm refactoring code, all the code I need to go fix. And I do it without adding types everywhere. I don't have to type every single individual variable because it's using type inference. And so you can actually, the type checker that's open source as part of HHVM is really interesting because it actually will color code the code not by syntax, but optionally you can color code it by the proof that the type checker has that your code is correct. And so you can take a file and look at it, and all of the green parts, the type checker knows you're actually using an object of this type versus that type, and you're not introducing a bug. You're not mixing up an ordinal key in an array with a user ID. And then you can also tell the parts of your code that you don't have good trust in, that you don't have good assertions because something's making the type checker blind to what's happening, and you have all of this red code that you need to be worried about. And this is something that quickly took off within Facebook and very rapidly, as Greg mentioned, shifted the entire code base over to being typed because every single engineer was getting a ton of benefit out of being able to reason about their code while still moving as quickly as PHP let them move. Other questions?
I had a question on invariant detector. It sounds like it's only checking the write operation, is that right? Is there any plans to do the read operation as well?
Hey, yeah, so we actually looked into this, and the overhead that we would add to every read operation on Facebook would be too much at this point, but it hasn't completely got off our minds yet. It's just that there has been so many changes that we could have done to write requests, and they're usually more dangerous. I mean, they are equally dangerous in the sense that you don't want people reading stuff that they shouldn't, but when you write to others people's data, it was just a first priority. And so the read overhead, it's much bigger than write at this point.
Hey, Marjorie, do you want to mention Privacy Enforcer in that context?
So we have another tool called Privacy Enforcer that our privacy team developed, and it's looking at read requests as well, and it's looking at the objects that are being read on the read request have gone through a data fetching framework that are actually checking those privacy rules that I've mentioned. so that we actually have like a proactive log that we can look at later to see all of the objects on the Facebook Tau API that have not been secured yet. So we can have teams systematically go through all of them and make sure they're all secure.
And so that ends up being a detection-only mechanism, where the nice thing about invariant detector is it can actually enforce and prevent bad things from happening. Cool. Other questions? There's one back here. There's one back here, Melanie.
Thank you. So I was a little surprised there wasn't more discussion or emphasis on anomaly detection, dynamic analysis of the systems as they're running to detect when something unexpected is going on. It may or may not be a security problem, but frequently security problems are detected as, oh, that's not what we expect. And as was mentioned by at least one of the speakers, the right person happened to see the anomaly and caught it, but that nobody else probably would have even recognized it as an anomaly. This is probably a question mainly for Karen with a background in machine learning, is do you see this as an area to be attacking or at least considering for future research and development, building the machine learning or the mechanisms into the system that understand what is nominal, normal activity and at least flagging or recognizing first and then perhaps categorizing and or quantifying the degree of anomaly associated with non-nominal behavior such that human attention can be focused and eventually programs and methods can be developed for preventing malicious anomalies.
Yeah, for sure. And we have a team that does that, actually. And some of the OS query stuff actually feeds into that as well. I think, like, from my perspective, when I was deciding, I knew I wanted to go into security. I knew I had the skill set, and I was deciding where to apply it. I saw a lot of other companies that are doing anomaly detection. I see a lot of other companies doing that sort of network monitoring stuff. And so when I was thinking about what I thought was the most exciting and what I thought was the most interesting, and also a little bit about what I wanted to speak about today, I feel like a lot of people identify that as a problem, and I just don't think that it's as cool as the stuff that we chose to do. It's definitely extremely important. It's a great application of machine learning. I just feel like it's not as exciting as some of those other more subtle applications. I think the focus of today, since that's kind of a more traditional application, I think today's really about opening up new opportunities and getting people excited about different ways to apply their diverse skill sets that might not necessarily come to mind. Anomaly detection, definitely super important. We have a whole team that does it at Facebook. I feel like it's just a very traditional application at this point, and so I was really excited to tell people about something that I thought was new.
Do you want to talk at all about detection and integration of OS query and other sensors for detection?
I don't have a mic.
Sure. Oh, okay.
God, it's in my shirt. Seemed like good at the end time.
OS query is the way that we generate signal across, amongst other things. So the way that the signal gets processed is we collect all the data we can, whether if it's anything that is running in those machines, and when we just classify that data through one tool that is called Blackbird, which is one of the things that does all the matching and pattern detection. And then we have rules that apply within that Blackbird. And then we can detect either if something is strange or something has gone out of a pattern or an unexpected pattern. So that's basically how the detection it's applied. It's definitely not looking at single alerts, it's to looking at patterns, because if you're starting to look at something that happened in some machine somewhere, when the order of magnitude of your machines is millions, it's completely useless. But when you see something that is generating a spike in a graph or something that completely doesn't really fit what that machine is supposed to be doing, that's the data that should be looked at. An incident response looks at that right away.
Awesome. One last question, right here in the third row.
So the conference is about security at scale. In terms of scaling, like we got a sense of the scaling issues with data, like somebody talked about, giving an analogy with a swimming pool full of disks, and then there was we got an idea about the size of the code, millions of lines of code. there is another dimension of scale. When you think of Facebook, we think of the millions of users who hit Facebook at the same time. And could somebody give a sense of what kind of security issues the scale of the number of users introduces, and what mechanisms are used to deal with that?
Yeah, I mean, I think for us and probably lots of other large sites, like one of the biggest challenges is how do you actually scale supporting people and helping them protect their account in ways that they can easily use and understand, and they don't get into trouble by turning it on as well. So like we have a two-FAC option, and lots of other sites do now as well, but how do we work together as an industry to drive those solutions down so that it's way easier and everyone's not building a one-off two-factor authentication solution? And how do you get back into your account, right? Like a lot of those security issues that affect individual people are how do they authenticate to their account? What do they do when they lose access? And how do you help individuals when there's 1 billion people using your site, or even 1 million people using your site is already hard. I don't know if other people have other thoughts on this.
Yeah, I think the other fun challenge that we face is just the diversity of users that we have. So we have power users who are incredibly technically competent, and then we have people like my grandma who clicks on anything. So it's really a challenge to build something that's accessible that makes people feel confident about being able to be in control of their own privacy settings, to be in control of their data, even knowing that a lot of them are not confident about computers to begin with. So that's really probably my favorite part of my job, is coming up with new ways to deal with all of these different diverse problems, knowing that my end user is often not going to be extremely technically competent, and maybe sometimes will even subvert what we're trying to do. So I think when you have that many people, there are a lot of different challenges, and just the diversity of challenges is probably the hardest and most exciting thing that we face.
Great. Well, that wraps up the Q&A for today. Thank you to all of our speakers for participating.